Today, I want us to talk about the basics. Data science. What really is data science? There is not actually a widely acceptable definition out there. But for me, data science is really about making optimal business decisions with data. Basically, leveraging data to make optimal business decisions and to make business impact. And that's very simple. But in order to do that, you have to do too many things, right? In fact, by that definition, we can now say that data science involves the collection of data, organizing data, storing data, presenting data, generating insights from data, operationalizing data into your business operating systems to really make better decisions. So data science actually covers all things data, from the raw data all the way to the end product that we've used the data to build. And it's really not about writing Python codes or writing Java or writing SQL or dashboarding or things like that. It's really about solving business problems. So most of the times, data scientists actually work very closely with business folks. So stakeholders, we usually call them. For example, maybe I'm a stakeholder and I have $100 million to invest in my marketing efforts. What is the best place for me to invest that $100 million to get the most return out of it? Data scientists can help me answer that question, right? Maybe you have a business problem where you just want to detect which transactions are fraudulent, okay? And you have some data about transactions and which one are fraudulent and all of that. So a data scientist can take that data, look through it, do a lot of things, and be able to tell you for every incoming transactions which of them are actually fraudulent transactions, right? Maybe you are a retail company and you just want to understand what is the best product to actually mark down on, and at what time should I actually mark down. A data scientist can help you solve that, right? So it's really about solving the business problem and less about just writing codes, crunching data, and all of that. So in simple terms, data science is about making sense out of the data and actually leveraging that to make very impactful decisions. The way I think about data science or data scientist is really a craftsman that has a toolbox. Okay, so you have your toolbox and you take with you your toolbox everywhere you are going. Based on the problem that you see, you open your toolbox and pick whatever tool that will solve the problem. So in this case, your toolbox may contain things like dashboarding, experimentation, statistical analysis, predictive modeling, machine learning. All of those are tools in your toolbox. And when you go to the problem solving, based on the problem that you see and you need to solve, you just pick what tool you need to use and then solve the problem. Okay? So to me, that is what data science is. Historically, data science has evolved over the years, and I would like us to actually look at some of the history of data science. In fact, I always make the joke that data science is really a marriage between an old man, and that old man is statistics. This has been existing for a very long time with a young lady, and that young lady is computer science. These two have decided to live together in peace forever. That's what data science is. But like I said, data science has been in existence for a very long time, and you can date this back to the 1940s. In fact, it started when neural net was first talked about in 1943, I believe. And I'm going to use this timeline graph created by Hazel to really illustrate the history of data science. So if you start all the way from the left, you see in 1943 neural net was a thing. And in 1962, I will pick that because that was a big milestone when John Tukey actually wrote an article, The Future of Data Analysis. In that article, he actually expressed his opinion around how he thinks as a statistician you have to actually also start thinking about empirical data and not only try to solve problems of inferential things, which is what we call inferential statistics. So I think Tukey's paper actually opened the minds of most statisticians to look more at data and use computer algorithm to actually analyze data. And then fast forward, there was, an article by Shapiro and Co., which is about from data mining to knowledge discovery in databases. In fact, that was a time when data mining was a thing where, we think of data as, a gold mine, and you can actually mine that to extract insights. Okay, that was around, 1996. But even between 1943 and 1996, so many other things happened, as you can see on the diagram here, like things like relational databases was established, business intelligence systems were built, so a lot of things were happening, throughout this journey. And fast forward to early 2000s, that is when we start to see a lot of big data because Web 2 became a big deal. At that time, Facebook of the world was formed when people can actually contribute to the internet, right? It's not like you can only consume information from the internet. You can actually also contribute it. You can like things, type comments, upload pictures. On YouTube also became a thing around the same time, and so big data became a big deal, and a lot of computing infrastructure was needed. Also, things like MapReduce, Hadoop, all of those things, started coming up around the early 2000s, and really that was when data science started actually rising, and the name data science, I believe, appeared as a job title around early 2010, around that time. But even before that, in 2005, there was a breakthrough when a book called Competing on Analytics, that was written by Thomas Davenport. In fact, that book actually opened the minds of businesses on how they can commercialize data and make sense out of data for their own profit. In fact, I still have that book right here, Competing on Analytics. Okay, this book was written in 2005 and it's still a very relevant book. And so you can see that around that time, data science was becoming more of a commercial practice. Okay, and then fast forward, I believe it was in 2012, if I'm right, the same Thomas Davenport and DJ Patil, who was then the chief data scientist of the United Nations, actually, the chief data scientist of USA, he actually said that, data science is going to be the sexiest job in the 21st century, and looks like it is really the sexiest job nowadays, isn't it? And then so fast forward, a lot of things started coming, artificial intelligence, machine learning, and now a lot of bars coming. But again, those are all tools. Data science is really making sense out of data using whatever tool you have. Okay, in order to really understand and appreciate data science in practice, as far as business is concerned, I'm going to illustrate this with the data science hierarchy of needs. So what is the data science hierarchy of needs? The data science hierarchy of needs was created by Monica Rogati. She actually used the concept of Maslow's theory of needs to actually carve out what we now call the data science hierarchy of needs, which actually illustrates what are the important things in data science in any business. So even though in the news we talk about machine learning, AI, data science is much more than that. Okay, so starting from the base, the most important thing or the basic thing in data science is first data collection. Okay, so under data collection you have things like data instrumentation, how to get data from logs and sensors. You may have external data, basically how to get data from systems. Okay, that is like the very first need of data science. And mostly the job title of people who do this type of work is usually software engineers or data developers. Okay, so that is like at the very the basic need for data science to function is to first collect data, because without data you can't do anything. Then once you collect the data, the next step is how to actually move the data or store the data in a place that you can actually use for analysis. So, how do you create reliable data flow? How do you get the right data infrastructure for your job? How do you create data pipelines? ETL jobs. Here's where you talk about structured data versus unstructured data. All of those happens under the second step, which is like moving or storing data. Okay, and usually these are done by data engineers. Okay, then after you kind of collect the data, you move or you store your data, then you can now explore or transform the data. So here we do a lot of data cleaning, data preparations, and mostly are done by data engineers or sometimes data scientists by title. Okay, and then you go to like analytics, creating metrics, creating segments, preparing data for predictive modeling, creating features. That's happening under the fourth level of needs, which is aggregating or labeling data. Okay, and then the next one above that is actually optimizing or learning from the data. So things like experimentation, A/B testing, or creating simple algorithms like regression, machine learning algorithms like decision trees, and really understanding and learning and optimizing from the data that you've collected. Okay, that is the fifth one. Okay, and then finally at the very top, that's when you go to the AI and deep learning and things of that nature. So you realize that even though in the news everything we hear is about AI, deep learning, and all of that, data science actually needs to first collect the data. Okay, being able to manage that data well by storing it well, be able to explore and transform that data, and be able to create metrics, aggregate, understand the business, understand the data, and then optimize the data via A/B testing, experimentation, things of that nature before you go to the AI. So many people don't do AI. Okay, many people in data or in data science don't end up doing AI. Some of them do, a lot of things in analytics, in just creating metrics or even creating reports. So, how your data science role is really depends on the size of the company. For example, if you work in a startup company, you might be the only person, doing everything in data science. So you might be the one creating, or collecting the data, storing it, creating algorithms, creating metrics. You might be the only one doing that. But if you are in a medium-sized company, you might be doing some data engineering, and maybe there may be another person or another group of people actually focus on creating metrics and things like that. But if you are a big company like Facebook, Google or Shopify and things like that, where you have a lot of money, you can hire a lot of people to focus on different areas, right? So in that case, at the very bottom, mostly software engineers are doing that. So the data instrumentation, logging, creating data from the system, those are software engineers. Then the next step, creating reliable data flows, pipelines, things like that. That's really about the data engineers. Okay, and then preparing data, cleaning data, really analyzing data, creating metrics, doing A/B testing. Those are done by the traditional data scientists. Sometimes they are actually analysts. Okay, but those are the people creating experiments, measuring experiments, creating metrics, and all of that. Okay, so that's the title, the core data science group. Okay, and then finally you have like machine learning scientists or machine learning engineers that are focused on things at the top. So you realize that data science is very broad and has many different components, but ultimately the goal of data science is to use all of these tools on data to answer business questions. So again, data science is all about solving business problems and using data to make optimal business decisions. I hope this was helpful. Talk to you all later. Bye bye.